Algebra 2, here we are with another log lesson. Solving basic log problems today. We've done graphing logs, we've done graphing exponential, we've done solving exponential, and now we're talking about solving with logs. Our first strategy with logs is going to be convert it back to exponential. Remember that a log is kind of like the inverse of exponential. I like to have the answer on the left. It's not a big deal if it isn't, if it's on the right, but you can either flip it around if you want to, or sometimes after a while you just get used to it and you can figure it out. I like to have it on the left. 2 equals log base 4 of x. So 2 is the power of base 4 that gives me x. So 2 is the exponent on top of 4 that would equal x. So 4 squared equals x. That's 16. The answer in the log problem is the exponent on top of the base that gives me that number. Okay? Let's do log base 9 of x equals 3 halves. So 3 halves is the exponent on top of base 9 that equals x. Okay, we could just type that into the calculator. 9 to the 3 halves power, or 9 to the 1.5 power. Okay. Or we could use our brain. We had fraction exponents a little bit ago. The bottom number is your root, so that's the square root of 9, so that takes it down to 3. And then the top number is your power, so 3 to the third power is 27. So that's another way to do it mentally in using our past knowledge from previous units. 27 equals x. Okay, this one's like that. Not quite as small. You probably do need your calculator for that one. So go ahead and push pause and give that one a shot. Alright, remember 5 halves is the answer going on top, or is the exponent going on top of 16. 16 to the 5 halves power equals x. Okay, we could type it in, or if we do the second root of 16, that's down to 4. And 4 to the 5th power is pretty big. It's going to be 1024. Or we could just type in 16 to the 5 halves power. Oops, messed it up. 16 to the 5 halves power, 1024. Okay, so sometimes x is not always right there. X can move around. What if x is over here? Now x is the exponent on top of 2. 2 to the x equals 1/4. And now we're right back at our exponential problems that we just got done with. Need to get a common base. Okay, it's a fraction, so it's flipped, so it's going to be a negative exponent. 4 is 2 squared. So that side is 2 to the negative second. 2 squared would be 4. Negative exponent flips it. So now I have x equals negative 2, the end. Okay, let's have you try that one. That one I think is pretty easy. Ready, set, go. Okay, let's see how we did. X is on top of 3. 3 to the x equals 27. Okay, we're trying to make them both be powers of 3. 27, hopefully we're getting our powers of 3 down. 27 is 3 to the third. And now we have x equals 3. One more set of these, and then we'll move on to the second type of log problem that we can solve. Alright, x is the power. X is going on top of a half. 1/2 to the x equals 4. Okay, so 1 over 2 and 4. So I'm thinking let's get these to be 2's. 1/2 is 2 to the negative 1. Power, parentheses, power, this is 2 to the negative x. On the right-hand side, 4 is 2 squared. So now I have negative x equals 2. Alright, so that would mean positive x would be negative 2. Let's take a look at this one. X is the power of 4. That equals 8. Alright, I think you're going to have to change both of them. Go ahead and push pause and give those a try. Alright, 4 is 2 squared. 8 is 2 to the third. Power, parentheses, power, we multiply. That's 2 to the 2x equals 2 to the third. So the exponents have to be equal. 2x equals 3. X will be 3/2 or 1.5. Nice. Not too bad on this side. Let's see what we have on the other. Solving with the same log base. So similar to our exponential ones where we had to have the same base and then we could set the exponents equal to each other. If we have the same log base, then we can put the parentheses parts equal to each other. Log base 2 of x plus 3 equals log base 2 of 10. So we've got log base 2 of something equals log base 2 of something else. That's only possible if the two somethings are the same. So x plus 3 needs to equal 10. Or x would need to be 7. Okay? Think about our graphs of original log. Okay? Just a regular log. How it's always x's are greater than 0. Okay? Whether it was a negative or a positive multiplier, we're staying right there. Our domain for the regular ones was x's are greater than 0. So I need the inside has to stay positive. The parentheses part needs to stay positive, greater than 0. Okay, we have log base 7 of something equals log base 7 of something else. So we got to put the two somethings equal to each other. Okay, we're going to put the two somethings equal to each other and solve. I'm going to subtract the 2x. And subtract 2. We'll have 6 equals 2x. We can divide by 2 and get x equals 3. Okay, for these equal ones, we should be able to double check this. 2 times 3 is 6, plus 8 is 14. 4 times 3 is 12, plus 2 is 14. So we have 14 there in both spots. When it's log equals log, just one log on each side, then we should be able to double check and put this number back in and have it be positive and equal. Okay? Let's see what happens when we have x squared gets involved. Okay, log base 2 of something equals log base 2 of something else. That means these two pieces need to be exactly the same. X squared minus 4 equals 3x. Here we go again, more factoring. Let's get everything on the same side. We're going to subtract that 3x over. So we have x squared minus 3x minus 4 equals 0. A pretty friendly factoring problem. What multiplies to negative 4 and adds to negative 3? We'll have negative 4 and 1. So x minus 4 times x plus 1. Okay, our zero product property. Two things multiply together to equal 0. That means one of the things has to be 0. What would make this one be 0 if x was 4? What would make this one be 0 if x was negative 1? So there's our two answers. Now we definitely need to test them. To make sure that they are equal and positive. Okay, so I'm going to plug 4 in there. 4 squared minus 4. Does that equal 3 times 4? 16 minus 4 is 12, and 3 times 4 is 12. Yes, equal and positive. So x equals 4 is good. What about negative 1? Negative 1 squared minus 4. Does that equal 3 times negative 1? 1 minus 4, that's negative 3. And this is negative 3. They're equal, but they're not positive. Equal, but not positive. That's what this little chicken scratch is going to say. Equal, but not positive. Okay, and our domain for these logs is that the inside has to be greater than 0. So this one's not going to work. That's the only one we'll take. Okay? You got the same type of problem over here. Let's see if you can push pause and see what you got on that one on the bottom right corner. Alright, log base 75 of something equals log base 75 of something else. Just threw in a really big log base to show you that it doesn't matter. The only thing that matters is that those two things match. So then now I can set those two pieces equal to each other. Okay? Set them equal to each other, get everything on the same side, factor and solve. I had 5 and negative 3. 5 gives me 10 equals 10, that's good. Negative 3 gives me negative 6 equals negative 6. Equal, but not positive. So we're not going to use that one. Just the 5. Alright folks, good work today. Thanks for following along. Hopefully that helps. Give that assignment a look and check it with the answer key on Schoology.